Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have this function f is equal to 2 plus x cubed times natural log of x, and we have to find the second derivative of this function. Now recall, in order to find the second derivative, we have to find the first derivative and then take the derivative of that new function. So let's compute the first derivative. Now f prime of x is d dx of 2 plus x cubed ln of x. Notice that this is a sum of two different functions, so we can compute the derivative of each one separately and then add them together. So let's split it into two different derivatives. One is derivative of 2 and then derivative of x cubed ln of x. Now for the first one, 2 is just a constant, so its derivative is 0. For the second expression, see, this is a product of two functions. One function is x cubed, the other one is natural log of x. So we have to apply product rule. And the rule says you keep one of the functions fixed, don't change it. So write it down, x cubed, and take the derivative of the second function. Then you switch their roles and add it. So you add, now you keep the second function as it is and take the derivative of the first function, which is x cubed. Okay, 0 will just go away, and let's evaluate these two derivatives here. So we'll have x cubed. So what is d dx of natural log of x? Just 1 over x. And then you just write down natural log of x, and d dx of x cubed using the power rule is 3x squared. So if we simplify a little bit, see, the first expression is x cubed divided by x, so it is x squared. And the second expression is 3x squared natural log of x. So that is our first derivative. So now let's move on and figure out the second derivative of this function. So what is f double prime x? By definition, that is the derivative d dx of f prime of x. And f prime of x, the expression is right here. So this is d dx of x squared plus 3x squared ln of x. Okay, we do the same thing again. See, this is a sum of two functions, so we can split it into two separate derivatives. So first we have derivative of x squared plus we'll have derivative of 3x squared natural log of x. Okay. Now, d dx of x squared, you can just use power rule. This is 2x. Then for the second expression, see, 3 is a constant. You can just pull it out. And notice we again have product of two functions, x squared times natural log. So we have to use product rule again. But also remember, this 3 has to be multiplied to the entire expression. So the best way to not make a mistake is write down the derivative of this expression inside a bracket and multiply 3 throughout, because there will be two different terms. So that's what we're going to do. So recall product rule again. You keep one of the functions as it is, x squared, take the derivative of the second one, and then add, keep the second function as it is, and take the derivative of the first function. Remember, again, 3 has to be multiplied to both terms. So let's simplify. So here, x squared, just leave it. ddx of ln of x is 1 over x, plus, keep natural log of x as it is, and derivative of x squared, power rule again, is 2x. So let's simplify everything and we will get our final answer for the second derivative. So the 2x is 2x. Then we have 3 times, see we have x squared divided by x is just x. And then the second term is 2x natural log of x. Okay, so this is equal to, let's write one more step here. We have 2x. Notice this 3 distributes, so 3 times x, and then we'll have 3 times 2 is 6x natural log of x. And as you can see, these two terms are similar. You can combine them together. So we will have 2x plus 3x is 5x, 5x plus 6x ln x. So that is the second derivative of the function. To finish, I want to make one more comment. If you go back to the first derivative, notice that those two terms that we have, you could have combined the two terms because you see that there's a common factor of x squared. So you could have rewritten it as x squared times 1 plus 3 natural log of x. And you could have used that particular expression to evaluate the second derivative. Your answer will be similar, nothing different, but you have to again apply the product rule from the very beginning. There wouldn't be a sum of two terms, but there would be product of two terms. And the same way, you just apply product rule, and you should get the exact same result. Thank you.